This example problem asks us to find possible formulas for the functions f and g shown in the figures below. We'll start first with the function f of t. As you start to examine the graph of f of t, you'll notice that it seems to resemble the graph of y equals sine of t. Notice how at t equals 0, the graph is at the middle. Then it goes to the max, back to the middle, down to the minimum, and then back to a middle. So it completes one period. Notice the amplitude of this graph is 1 because the distance from the middle to the max is 1 unit. Same with the middle to the min. The only difference from the graph of y equals sine of t appears to be how long it takes for this graph to complete a period. So it will take 4 pi, rather than typically the graph of y equals sine of t is 2 pi. For this graph, we would define that the period equals 4 pi. We know that functions y equals sine of bt and y equals cosine of bt have periods of p equals 2 pi divided by the absolute value of b. Well, we know the period, p is equal to 4 pi. What we don't know is what that b would have to be when we write our potential formula for this function. So we could state that we know 4 pi is equal to 2 pi divided by b. So we could solve for this b by multiplying both sides by b, and we would end up with 4 pi times b equal to 2 pi. And now we could get b by itself by dividing both sides by 4 pi. So we would have b equals 2 pi divided by 4 pi. Notice there's a factor of pi in the numerator and denominator. So we have then simply 2/4, which we could reduce down to 1/2. So we see that our constant b would be 1/2. And since the graph resembled y equals sine of t for everything except the period, we could now write our possible formula for our function f. So our possible formula would be f of t equals the sine of 1/2 times t, where the 1/2 times t would all be inside of the trig function of sine. Now let's turn our attention to the graph of g of t. Now you notice with g of t, we start at t equals 0 at the max, then it goes to the middle, the minimum, the middle, and back to the max. And then it starts all over again and repeats. When you look at this, we notice that the amplitude of this graph is 1 because the middle is at y equals 0, and the distance from middle to max is 1. Distance from middle to minimum is also 1. Now when we look at this graph, it appears that it resembles the function y equals cosine of t. That's because when we're starting, it's starting at the max, then decreasing, and then increasing. We've already established that the amplitude is 1. What's different from the graph of y equals cosine of t is the fact that the period is not 2 pi. In fact, the period in this case is 20, as it takes 20 units to complete one cycle. Now, just as we did for our last graph, what we will need to find is our constant b. So we will state that p is 20 and p is equal to 2 pi divided by b. So if we solve for b, we'll have to multiply both sides by b, and we'll have 20 times b equal to 2 pi. And then to get b by itself, we should go ahead and divide both sides by 20. And we have 2 pi divided by 20. And the 2 and the 20 are both divisible by a factor of 2. So we could rewrite this as b being equal to pi over 10. So now we've found our constant b based on our period being 20. And now we can go ahead and write a formula for g of t. It will be equal to the cosine, and inside the cosine we would have pi over 10, our value for b, times t. So let's conclude our problem with a recap. Our graph of f, we could write a formula, f of t equals sine of 1/2 t. And for our graph of g, we wrote the formula g of t equals cosine of pi over 10 times t. Notice in both cases how both of them differed from the graph of y equals sine of t and y equals cosine of t respectively is based on the fact that the period was not 2 pi. In the graph f, the period was 4 pi, whereas in the graph g, the period was 20.